Hey guys, hope you did well on your quiz. Now that you're done with that, let's go ahead and talk about the notes for today. Take a second, you can pause this if you want to just kind of think through these problems and try to figure out their answers. Did you pause? Did you really do it? I hope so. So as you look at these problems, what are these possible answers? 2 to what power will give you 64? You might have to count a little bit, but it's 2 to the 6th, I believe. 2 to the 6th is 64. 3 to what power would give you 1/3? This one's tricky. Remember you learned in Algebra 1 that a negative exponent flips it. So 3 to the negative first power would flip it down to the bottom. 8 to what power gives you 1? Remember, anything to the 0 power is 1. Oh, 7. Who knows their powers of 7? Nobody. But recognize this number. 7 to the 3rd is 343. Practice that one. Oh, here's another one, the fraction. It's kind of like number 2. 9 to what power will make a fraction 1 over 81? Well, I know that 9 squared is 81. To flip it down to the bottom, that exponent must be a -2. Fun, huh? And then the last one is another big number that you probably don't recognize, but it helps you to be familiar with it, just like 343. 216 is 6 to the 3rd power. Okay, so that missing number, that missing exponent would have been a 3. Why are we thinking about this? Well, what we're going to be doing in the next part of this unit is learning about logarithms or logs, and this is what logs are. It's how do we find that missing exponent, okay? Now, mathematicians don't like to write it like this with a question mark, and we don't even necessarily like to write it like this all the time. They don't like the x up in the exponent. They want another way to say it. And so what they did is they invented logarithms to help us do that, okay? If you go on Google Classroom, there is a link to this notes as a PDF. If you have access to a printer, you're welcome to print it. If not, you can just do it along with me, just on plain old paper. As I look at this lengthy, crazy explanation of what you would find in a textbook about what a logarithm is, these are the basic ideas I want you to take away. The logarithm function with base a, where a is greater than 0 and a can't be 1. So a is your base, and your base is always going to be greater than 0, but also it's never going to be equal to 1 exactly. And the way we usually write it is log base a, it's like a little subscript of x. Log base a of x. Say it with me. Log base a of x. Okay? Let's say that that was equal to y. What that means is that a to the y power equals x. A to the y power equals x. That's what this log problem means. And we're going to do a bunch of examples today. You'll get the hang of it super fast. It just takes a little bit of practice, okay? It's important for you to know that logs and exponents, logs and powers are inverses. They are inverses of each other. I think it's next class, maybe the class after, we're going to look at graphing logarithms without our calculators, and we're going to need to know what an exponential growth graph looks like so that we can figure out what the inverse log graph looks like. It's so exciting. All right, so the last thing here is it does talk about the domain of a logarithm being x is greater than 0, but we're going to get into that next class, so I wouldn't really worry about that yet. All right, so for now, these are the big ideas I need you to take away. All right, so what we're going to do in these first examples is we're going to change these powers into logarithms, okay? So to turn it into log, the first thing you got to write down is the word log. And the base of the log would be the base of the power. It would be that 3. And the way I like to figure out where everything goes is I kind of draw these little curly cues. It's going to be the 3, then the 9, and then equals the 2. Cool. This is going to be your exponent is the answer. The answer to a log problem is always what was the exponent. Just like we were looking at back here. If this had been written as a log, the answer was what was the exponent. Now that answer being an exponent doesn't mean that it's written like a little or superscript, like tiny font floating in the air. It's just a regular sized 2, but the answer is whatever the exponent number was, okay? So log base 3 of 9 equals 2. Some other helpful things to remember. The base number is the base of the exponent. And the 9 was like what was the answer before. And I write this base answer exponent, base answer exponent, because bay means something and I always forget what it means every year. And I need my students in my classroom to remind me. I think it's before anyone else. Is that right? So this is your bay. This is how you remember is bay. Okay. I'm so not hip. Okay. So then the next one, we're going to change this exponent into a log. So first thing, write down your log. Your base is A. The answer is 24 equals the exponent is 4. So you start with the base, the 24 comes next, equals the 4. Same thing here. The base is 2 of 15 equals your x. Just put the word log in front. Log base 2 of 15 equals x. Easy peasy. The next 3 are going to go the opposite direction. Here we're going to start with logs and turn them into powers, okay? So the base here is 2. The exponent is going to be a 3. And the answer is going to be 8. So bay. Okay, and this, you can use the curly cues again if you want as well. 2 to the 3rd equals 8. Your base is 2. The exponent is 3. The answer is 8. 2 to the 3rd equals 8. And that's really easy to check because you guys know 2 to the 3rd is 8, right? You know you wrote it correctly. Try that here. Using the little curly cues. 3 to the x equals 2. Base, answer, sorry, base. This becomes your exponent, and then the answer was 2. Bay. Okay. This one is a fave. So in C, it's a little bit tricky. You might notice that the base, the little subscript number, is missing. If the base is not showing, then the base is 10. This is called the common log. And if you're doing this on your own paper, take a second to pause and write down these problems as I'm going. If I'm going too fast, you can slow me down or pause. Make sure you're writing down these vocabulary words as well. Common log is when the base is 10. So I guess what happened was mathematicians just got tired of having to write the base all the time, and they commonly use the base of 10. It was very common to use that. So they're like, you know what, guys, let's just all agree. Let's be lazy. Let's do a shorthand. If we don't write the base, that means we mean it's 10, okay? Kind of like when we do a square root. What the number, the square root of 9 say, that missing index, that 2, is never written because it's a square root. We know that when I just write that, I'm talking about a square root, not a cube root or a fourth root, okay? So this is another example of that, okay? So that base that's missing would be a 10 to the a equals 6. 10 to the a power equals 6. All right, let's take a look at another step. Another log that is special that I want you to be familiar with is when the base is e, okay? Remember this number e, it's called Euler's number or Euler's number. It is around 2.718. You saw it when you graphed exponential functions, okay? If the base is your e value, then this is called a natural log. A natural log is when the base is e. It is abbreviated as ln. Pretend like it's French. Log naturel. Yeah, that's ln is the natural log, okay? And it is the inverse of an exponent with the base being e. So if I had ln of 4, this ln means log base e of 4. That's what the ln means, is log base e. This is what I call bad math grammar. You never write log base e in math. You always write ln. It's just like the proper way to do it, but they mean the same thing, okay? So if I wanted to rewrite this, I would do e to the x equals 4. Easy peasy. All right. Again, pause, write down, try some of these on your own if you need to. You can always rewatch if we need to, okay? If I'm going too fast, you can always slow it down. All right, so we're gonna do some log evaluating, and this is going to be without our calculators, always. Welcome to pre-calc, right? My brain, especially this early in the year when I'm just remembering how to do logs, maybe you saw them a little bit in Algebra 2 last year, my brain does not work in logarithms. So when I do these problems, I always change them into exponents. It's just how my brain thinks, and I bet yours thinks the same way, okay? So log base 2 of 4, that means 2 to what power gives me 4? If you rewrite it like that, 2 to the question mark equals 4, or you can do 2 to the x if you want because you're fancy, that's fine. 2 to some power equals 4. That's so easy. You know that. The missing number is 2. 2 squared is 4, right? Done. So much easier to think about. Let's see this one. Doing my little curly cues again. This means 3 to a power gives me 9. What would that missing number be? 2. Cool. One little thing, maybe two little things. When you write your answer, remember the answer is just 2. It's full size, it's normal. It's not like question mark equals 2, like floating up in the air like an exponent, okay? The answer is just 2, not a floating 2, okay? The other thing to remember when you write your answer is don't just do this. Don't give us this entire red equation as your answer. The answer is just, what is that question mark? The answer is just 2, not 3 squared equals 9. Okay, the answer is just 2. All right, let's try number 3. Log of 10 equals 1. This is equals question mark. Notice this is one of those tricky ones where the base is missing. Okay, what is that missing number here? When the base is not written, it's a 10. So this is 10 to what power will give me 10? Oh, well, when you say it like that, it's easy to know. The answer is 1. 10 to the first is 10. Let's try this guy. 2 to the third will give me what? 2 to the third gives me what? Oh, well, that would be 8, right? 2 to the third is 8, not 6. Be careful. The next one, okay, this is tricky because there's no base and it's got a question mark inside. So remember, no base means that the base is 10. 10 to the negative first equals question mark. 10 to the negative first equals question mark. Well, the question mark's already by itself. All we have to do is simplify 10 to the negative 1. You should know that a negative exponent back from Algebra 1 is going to flip that down to the bottom. Exponent becomes a positive, and you would need a 1 on top. So this is just 1/10 is your answer. And our last one, 3 to the negative 2 equals question mark. What would that be? Negative exponent's going to flip it down to the bottom. Exponent becomes a positive. You would need a 1 on top, so this would be 1/9. 1/9 would be that missing question mark. All right, great job on these guys. Let's take a look at some more examples. As we start getting into these, if you start getting the hang of it, try to pause the video and try it for yourself. Okay? Maybe you need some time to write them down first. That's also fine. Try some of these for yourself before you just watch the video and see all of them directly. Try to do them yourself. All right. So I would say these next 6 are a little different from the previous 6 because there is no question mark. There is no equals. But it's the exact same idea. You just want to put the equals question mark or equals X. You want to put that in for yourself, okay? So this problem, log base 13 of 169, that means 13 to what power will give me 169? Hopefully you know that power would be 2. 13 squared is 169. If you don't feel super comfortable with all of your powers, think about pulling out a piece of paper, going on Desmos, going on your calculator, going on an internet search, and practice and review those powers. Powers of 2, powers of 3, powers of 4, powers of 5, 6, 7, 8. At least do all your squareds up until probably like 15 is probably good to know, all the way up to 15 squared. Okay, practice those. All right. The next one, put my equals question mark here. 2 to what power is 32? Pause it if you need to. 2 times, another 2 would be 4, times 2 is 8, times 2 is 16, times 2 again is 32. That was 5. Powers of 2s we use a lot, okay? This guy, oh, he's a fun one. I'm gonna call it equals question mark. 81 to the question mark equals 9. Were you able to set that up for yourself without me? All right, so this is a weird one because 81 to a power has to get smaller and become 9. Well, I know that 9 squared is 81, but how do I go backwards? How do I start with 81 and end up with 9? I think I'm gonna have to square root it, right? Isn't that what I have to do? The square root of 81 is 9, you remember that, right? So how do I write that as a power? Do you remember power over root from Algebra 2? Okay. When you have a radical, you can rewrite that as a fraction exponent. You can rewrite a radical as a fraction exponent. The power would be 1, the root would be 2. This is 81 to the 1/2. Do you remember that? If you don't, write it down right now with me. A square root is like a 1/2 exponent. A square root is a 1/2 exponent because the power is 1, the root is 2, so it becomes 1/2. For practice, a cube root is what kind of exponent? It's a 1/3 exponent. Okay, something to a cube root is the same as doing it to a 1/3 power. All right, good review. So this missing question mark here, to make it go like a square root, I'm gonna have to do a 1/2 power to make it go from big 81 to small, just 9. All right, let's take a look at this next one. This means 3 to what power gives me negative 81? Take a moment to think through that. Three to what power is negative 81? Well, let's see. Thinking about my powers of 3, 3 to the first is 3. 3 squared is 9. Times 3 again would be 27. Times 3 again would be 81, right? 3 to the fourth gives me 81. Is there a way to make that negative 81? If I made it a negative power, would that make it negative 81? Nope. A negative exponent, remember, is going to flip it. Would make it 1 over 81, not negative 81. Does it have to do with a radical like we did up here? Should it be to the 1/4? No, that would mean you're going to have the power over root. You're going to have the 4th root of 3. The 4th root of 3 is definitely not 81. We're going the wrong way. That would be some crazy small decimal. Is there any way to do 3 to a power, 3 times itself a certain number of times, and end up with a negative answer of 81? The answer is no, it's not possible. None of these guys are going to work. We say that this is undefined. It has no solution. It does not work. You can never take a positive base, raise it to a power, and get a negative answer. It's not possible. Okay? There's so many things I could tell you about that, how it connects to the graph and the range of the graph, but we don't have time for all that, so I need to settle down. But this guy is undefined. If you printed out this sheet, at the bottom of your page, you have some rules down here to memorize. And this is the first one. Actually, I wrote it as the last one, but that's okay. This is a rule you need to memorize. If you're writing this down on paper, put this guy down. A log, no matter what your base is, whether it's a base of A or a natural log, which is a log base E, if there's a negative number inside there, it is undefined. It is not possible, okay? You're never going to be able to do log of a negative number. All right, let's move on and try another one. Again, you can pause and try this at your own pace. Slow me down or speed me up. Let's see, log of 100. That base is missing, that's a 10. 10 to what power is 100? You got this, guys. Not 10 to the 10th, be careful. 10 to the 10th, I always see it every year. 10 to the 10th means you would have 10 zeros at the end of your number. Too big. 10 times 10, 10 squared is 100. So the power is 2. This guy, let's see, 6 to what power is, ooh, a fraction, yuck. Now that 216 number should look familiar. We saw him a few minutes ago. Where was he? Here he is, 216. Remember that guy? 216. That is 6 to the 3rd power is 216. What am I going to need to do to the exponent to make it go into a fraction? You're going to need to make it a -3. Cool? Maybe you can write yourself a note here. A negative exponent flips into a fraction. Cool? Maybe that's a note you need to write down for yourself to help you remember. When you're ready, let's try the next ones. All right. So another log where the base isn't written, that would be a base of 10. To what power is 1/10? That missing number would need to be a -1. Because 10 to the -1 will flip down to the bottom, exponent becomes positive, put a 1 on top. That's going to give you 1/10, that -1 exponent. The next one is fun. Take a look at this guy. All right, this says 2 to what power would be 2 to the 4th? As you look at that, you could simplify the 2 to the 4th if you wanted to, but it's actually easier to just leave it as is and just use your brain. 2 to what power equals 2 to the 4th? just 4, right? The answer is just 4. That missing exponent would be a 4. Okay, so this example is actually a really great example. It relates to something at the bottom. Write this down if you didn't print it. It relates to this rule right here. I don't know why I did all these rules out of order, but that's okay. When you're doing a log with base A, and then inside that you're doing A to a power, because logs and powers are inverses of each other, they're going to cancel each other out and undo one another, okay? Logs and exponents are inverses, so they cancel. Log base A of A to the M, these guys cancel each other out, and all that's left is M. Your answer is just whatever that leftover exponent was. Not little floating in the air, just a regular normal size answer. That's all that's left. And that's exactly what we just did here. Log base 2 of 2 to the 4th. These guys are inverses. Inverses cancel. The answer is just 4. Do you see it? Because if you see it, you're going to save yourself some time. Log, where the base is the same as that power, they're going to be inverses and cancel each other out. Let me see if I can find another example of that. I see a couple. Do you see any? Pause if you want. I see one here in number 18. Look, log base 4 of 4. These guys are inverses, so they're going to cancel out. Bye-bye, see you never. The answer is just 20. Cool. If you didn't see it right away, you can rewrite it. You would say 4 to the question mark equals 4 to the 20. 4 to the question mark equals 4 to the 20. What is that question mark? It's equal to 20. Cool. There's at least one more on this screen. Does anybody see it? Another one on the screen? It's number 15. This guy, when it just says log and the base isn't written, remember that base is a 10. So log base 10 of 10 to a power, those guys are going to cancel. Our answer is just 0.17. No work needed because you know that those inverses cancel out. And it just saves you a lot of time if you can see that. Okay. There's even more on this page. Do you see it? It's this one. Actually, there's a couple. Yeah, I love these. They're so fun. Okay, this is another example because ln of e to the 3rd. ln is just a fancy way of saying log with base e of e to the 3rd. So log base e of e, bye-bye. These inverses cancel. The answer is just 3. Pretty cool. All right, let's look at some more. Let me go back to the ones we skipped over. Let's go back here. So let's look at number 9. Oh, this is a fun one. Does anyone see it? ln of e to the 5th. What does ln mean? It's a log with base e. Everyone always gets freaked out by ln's, natural logs, but it's just a log with base e. He's just kind of special. Log base e of e to the 5th. Now do you see it? These guys are inverses. They cancel out. The answer is just 5. I love math. It's so cool. All right. So try to practice those inverse canceling ones. They show up all over the place. You might even see more today. All right. Let's take a look at number 10. I think that says log base 3 of 1. So 3 to what power is 1? Take a moment to think that through. Is it negative? Is it 0? Is it a fraction? 3 to what power gives me 1? 3 to the 0 power gives me 1. And you knew that, right? Because you know from Algebra 1 days that anything to the 0 power is 1. So that actually leads us to another guy at the bottom. This is a special log that I want you to memorize as well. Anytime you're doing a log, no matter what the base is, any base, even ln, natural log, which is log base e, when there's a 1 inside the log, the answer is always 0. And the reason why is because it means anything to the 0 power is 1. Anything to the 0 power is 1. Oh, well, when you say it like that, Miss Groses, of course, it makes sense, right? It's the exact same rule that you learned in Algebra 1, just written all fancy in log speak, okay? Anything to the 0 power is 1. You know that. So you now know that log of 1 is always 0. Log of 1 is always 0. All right, going back to number 11. Ooh, 1/2 to what power is 16? That's going to make your brain think a little bit. Let's see. How do we think about that? There's so many things. Let's see. What if it was just 2 to a power? 2 to what power would give me 16? Do you know that power? That would just be 2 to the 4th, right? Well, what do I need to do to make it from a 1/2 into a 2? What else do you think we need there? Do we need a 0? Do we need a negative? Do we need a fraction? What do we need to have in the exponent so that the 1/2 fraction flips into a whole number? I think the key is we need it to be a negative exponent. I think we need it to be a negative 4th power. Let's look at how that works out. If I was my Algebra 1 days, I would write that as 1 to the negative 4th and 2 to the negative 4th. They each get the exponent. And then they both flip because they have negative exponents. Exponent becomes positive, flip, exponent becomes positive. 2 to the 4th is 16. 1 to the 4th is just 1. You see how I got there? It's a hard one, okay? 1/2 to a negative 4th power. The negative is going to flip it into a whole number 2. The 4th power, 2 times 2 times 2 times 2 is going to give you that 16. So that missing number is a negative 4, is what our exponent needs to be. That's hard. All right, the next one. 2 to what power is 2? Oh, Miss Groses, that's easy, right? 2 to the 1st is 2. I knew that. Cool? All right. Let me show you another reason why you knew that. Did anyone notice? Log base 2 of 2. What did we call these two things? Log base 2 of 2. Those guys are inverses of each other, and they are going to cancel. They cancel out, and all that's left is the exponent. I'm out of colors. My exponent that would be left would be a 1. My exponent that would be left is a 1. Okay, so that is that inverse canceling rule again. This rule here from the green bubble. They cancel out. I wrote it here as its own special rule, but it's actually related to this guy. Okay. logs and exponents are inverses of each other, so they cancel each other out. So if you have log base A of A, the exponent would be a 1. This guy cancels out. 1 is all that's left. Natural log of E, this would be an exponent of 1. Natural log and E are inverses of each other. They cancel each other out. The answer is just 1. Okay, so if you can memorize these formulas, these rules here at the bottom, it's going to save you time. Okay, and you'll get better with logs as you practice, I promise. They're very difficult at first, but after some practice, you really start getting the hang of it. All right, what do we think about 13? There's that ln. It always freaks everybody out. ln just means a log with base E of E. So the ln I'm just rewriting as log base E. Let me rewrite. I'm going to color code it for you. The ln part is log base E. Then we have an E, and we're going to make it equals question mark. Okay, do you see where all that came from? You might see a shortcut. If not, rewrite it as a power. E to what power will give me E? Well, of course, that question mark has to equal 1. There's our answer. If you notice the shortcut, these guys are inverses, or you maybe even saw that they're inverses back here. They cancel out. All that's left is the exponent. Our answer is 1. Okay. So lots of ways to see it. Your choice on what makes sense for you. That they're very doable after you practice a bit. All right, let's jump down to number 16 since we already did 14 and 15. 5 to what power is 0? Let's think about this one. 5 to what power is 0? Is it 5 to the 0 power? No, because that's 1, right? Anything to the 0 power is 1. We learned that. We reviewed that. That's not right. Is it a negative? Like -1? No, that's going to flip our answer into a fraction, right? Is it a fraction exponent, like a 1/2? No, that's a square root. 5 times itself, how many times is going to get you down to nothing? It's not possible. Cool. This guy is undefined. None of those are going to work. It is undefined. If you looked at the bottom of your page, you might have noticed this guy as well. Anytime you're doing a log, no matter what the base is, natural log or any base, when there's a 0 inside the log, it is undefined. It is not possible. You can never do log of 0. You can never do log of a negative number. Both of those are undefined. All right, guys, you're doing great. This last one. Ending on a high note. All right, so this guy, natural log of the square root of E. This ln, let me color code for you. ln means log base E of square root of E equals question mark. You might be thinking that these inverses, or that these guys are inverses and they're going to cancel. You're right, but be careful. When they cancel, they don't just leave a square root symbol. It's not just bam. Cool, it's not just a floating square root by itself. It needs to be, what was that exponent? Needs to be, what was the exponent? So before you cancel, think about this. A square root is the same as e to the 1/2 power. Where was that slide? Remember this up here? A square root is the same as a 1/2 exponent. Square root is a 1/2 exponent. Same thing here. Square root of e is e to the 1/2. Power over root. Bring down that log base e in front. Now you can think about these guys canceling out. Inverses cancel. And our answer is 1/2. That's what we were missing. It's a lot, but you did great, okay? And remember, you can always rewatch this, review this as you need to. Hopefully it really helps to kind of solidify how these logs work and what they mean. Moving forward, we're going to be graphing them and eventually solving them. We're going to learn some properties of logs. There's so much to deal with logs in pre-calc. It's very exciting. But you got to have a solid basic understanding of what logs are before you can move forward. All right, so that's it. Your homework is on Google Classroom. Thanks for watching this video, guys.